Good morning, and thanks for joining us today. This is our second lightning talk in our Experience First Data Center series. Today we'll talk about simplified day 2 plus operations with Apstra for our next-gen data center. My name is Majid Ansari. I'm an architect on Cloud Vertical, and we have Jeff Doyle with us. We all know Jeff and thank him for educating many of us through his books, videos, trainings, and blogs. Jeff?
Hi, good morning or good afternoon, depending on where you are. And thank you for joining or for watching our video.
Thanks, Jeff. And folks, we have one more upcoming session that would be focused on APIs and automation. This session is focused on operations with Apstra. So to get started, I'll quickly recap on what we covered in our previous session for data center architecture. Then we'll talk about what would be some of the essential characteristics of a fabric management solution when it comes to simplified operations. And then I'll hand it over to Jeff to talk about intent-based approach for EVP and data center operations that's managed and supported by Apstra. So let's just jump right in. So a quick recap, and based on the last session, we actually concluded that EVP and VXLAN offers a very efficient and scalable solution when data centers have to deal with supporting legacy as well as next-gen architectures. And you could do an L2 stretch as well as you can offer pure IP L3 connectivity using EVPN. The second thing we talked about is to manage your data center, you need a sophisticated solution so that because complex requirements means complex parameters and then a lot of things that you need to deal with. You need a sophisticated solution when it comes to fabric management. And we, I think, showed a demo and talked about how Apstra can meet and exceed the requirements for day 0 and day 1. And basically what you need is a unified solution for seamless automation from day 0 to not only day 1, but day 2 plus operations. And that's going to be our focus on our discussion today. And Apstra definitely meets and exceeds all those requirements that we showed for architecture. Let's look at some of the things that we need to look into when it comes to operationalizing a modern data center. And then real quick, again, this slide is also a recap on some of the details we covered when it comes to day 0 and day 1. And then when I say day 0, day 1, maybe just a quick thing is like day 0 would be your ZTP, bringing up the devices, planning ahead of time on how your connectivity is going to look like. And we covered in details in our first session on what are some of the key characteristics of your fabric management solutions. Today we'll focus, as we talked, on the next 2 sets of characteristics, which will be focused on day 2 operations. So I will quickly with that jump into our first aspect, right? When we are operating a network, first thing I would like to say is it's very important for you to know how your network is operating compared to what you have it designed for, right? So you want to match your intent with what's the current operational state in your network. And in order to do that, right, you need to collect a lot of information. And there are ways that network equipments do support today, going from legacy SNMP or syslogs to recent developments with telemetry that can give you all that data in matter of seconds, right? However, you just don't need that raw data. What you would need to do is you need to analyze that data. You need to identify what is more important that needs to be reported. And then you also need to identify what's the relationship between the event, right? Like if a BGP session goes down and an interface goes down, how do you relate that, hey, these two things are related? And you don't want to see like thousands of alarms popping up on your screen. And then you have to manually figure out. That will take forever. So basically the solution needs to be able to extract knowledge from all the data that you're getting from the network. And the data that's coming in, now one key aspect, if you want to quickly analyze and see what's relevant, you will heavily depend on how your data that you're collecting is stored. It needs to be stored in a way that it's easier to query based on the context, right? And then when you do that, then you will see and you will get what you're looking for right away, rather than spending too much time trying to figure out what happened. Now, when you like want to have, and when I say that you need to store in a format that's easier to query, what do I mean is, as per the requirement, you need to know the relationship between different events. And the way you want to do it, and in one approach, and I think we found that approach to be very efficient, is network is like a graph. You have nodes and you have links. And similarly, you have relationship between those nodes and links, right? So what you do is you would like to have a format that closely aligns with that, and when you want to query, you get the same natural relationship that you would expect on your nodes, your links, your protocols, and on all those things. So a graph database actually offers that natural way of doing it, and then a graph database could store those complex relationships. Because when you talk about a network and what you see in the physical level, I would say just the tip of the iceberg, because now a network has lots of nodes, and if I go into like maybe a little bit technical jargon, you have protocol session. Each protocol session would have some routes that would be coming in, and then those routes will have next hop that it would be pointing to, or the tunnels that it need to follow, right? So all those things are complex relationship that you would need to understand. And in short, what we have found is a graph database would offer that kind of storage, as well as easy retrieval method, right? Very flexible, because now you don't have to know ahead of time how these elements are related, because a graph database is very flexible in that sense. So that would give you what you're looking for, and then you can actually see and compare with what you have versus what you're gonna get in the network in real time. The second aspect is, now when I say you need to compare it with what you have, you got to establish a source of truth, right? And if you have thousands of those devices in the network, and this state is distributed across those thousands of devices, it's not easy to compare across those, right? So that means your network is not a single source of truth. You would need like a central mechanism where you're going to store this information. And when I say source of truth, it could be, ranging from the way you have defined your connectivity, the way you have defined your configuration. So like configuration that goes on each device, operational state, BGP sessions. You're going to have these BGP sessions. They're going to be up, down. What do you expect them to be? Each of them going to carry routing information. How many routes should I have in a steady state? How many ECMP groups I do have in a steady state? So all that information will be stored in a single place in, for example, a graph database, and now you can easily compare with what changes. So this gives you that perspective. And now with the relationship that you have stored, you can now get things in context. And I think it's very important to have things seen in context, because if you don't have that, then that data may be meaningless or may not mean anything, even if, let's say, it's a big red alarm, but if you don't know what happened, it may not help you that much. So again, you have to present yourself, that the tool needs to present you that information in context. And for example, a BGP session went down because a corresponding interface went down. And having that information in that format helps you quickly take action and remediate it. So that, for example, your outage is limited, or if there's any security issue that you're running into the network, you can contain it, because now you know what to contain and then where to contain it. So I would probably stop at that on details about analytics and the knowledge you need to extract and how it helps you compare your intent with what's there in the operations state. The next thing that an operations team has to deal with, and I think it's probably the most important aspect of operations, is you want to be able to deal with any change in the network reliably. And when I say a change, it could be a planned change or it could be an unplanned change. A planned change could be a maintenance window where you're bringing down a device for an upgrade, or unplanned change could be that a router rebooted. All those things needs to be handled in a way that it's predictable, and then you can go back to a working state in a graceful manner with a minimal loss, right? And again, going back to the way we are storing our information, you can do that because now if you bring a device for maintenance, you exactly know that what is going to happen when you take out this device, and then you can accordingly alarm the system. So for example, if device is down and then your BGP sessions to that device are down, what it means is that you don't have to raise an alarm on your system that your 75 BGP sessions are down. Because you know that this system is going to be down, it is a maintenance, you will present it in a way that that's useful for the operators and not worry about things that they don't need to worry about. In the same way, you want to do your maintenance. Again, if the router reboots, now you will get all the relevant stuff that you need to see. So this is definitely like one of those things where you want to build a system or have a system for your fabric management that enables you to do these things smoothly. And examples are, I talked about, you want to do smooth maintenance windows. When you're going through the maintenance windows, you want to make sure your maintenance windows are meant and then done easily. Or you want to, for example, you made a change 2 a.m. at night, and then you come back in the morning and realize that something went wrong, and you want to be able to quickly go back and roll back your state across the network so that it is operating the way it was operating before you made the change. And this again is like a key thing where now you're treating your entire network or network state as an entity rather than dealing with discrete elements, right? And then you can deal with the network a lot more efficiently if you have that full picture and you can see that everything is operated as a system the way it needs to be, versus individual elements that may be operating fine, but then together it's not. So that's another aspect that you have to keep in mind is looking at the network as a system, being able to make changes across the network or roll back changes across the network, and all these things. I think I'm just touching some key things, but these will help you narrow down your root cause of the problem, or what we call mean time to repair, or also we also call it as mean time to innocence. So this this kind of approach would help you manage your network a lot more smoothly. And I think as I said, we will go through some of these in the later section as well. So I'm just going to stop at that, and hopefully I highlighted some of the things that are important for operating a next-gen network. If you have any feedback, or you see some of these things are relevant to you or not relevant to you, and then there's something else, please leave us feedback, and we definitely would like to go back and address those as well. But with that, I would like to pass it on to Jeff so that he can show us in real time and from an Apstra perspective how some of these things are addressed with Apstra. Jeff, I'll stop sharing my screen, and then maybe you can take over.
Great, thanks, Majid. I appreciate it, and I want to reemphasize something that is hugely important that Majid said, which is that the key to intent-based networking is seeing your entire network as a single, as Majid said, a single system, a single homogeneous entity. Certainly you can say, well, I can view my network that way, but what you really can't do, what any human operator can't do, is view the real intricacies that are necessary to see your network as a single entity. But if you can operate your network that way, if you can view your network that way, that is what allows intent-based networking, which is simply an expression of your expectations of the network. And once you have intent-based networking, you're able to more easily validate your intents, your expectations for the network. You're more easily able to say very simply what your new expectations are of the network. You're more easily able to monitor when your network drifts off of your expectations. And it opens, as I'm going to show you, it opens the door to intent-based analytics. And Majid talked quite a bit about that, of being able to look at this flood of data, either when your network is in a steady state and you simply have, you want to query your network for certain kinds of information, maybe for planning, or implementing new applications, things like that, or especially when you're doing troubleshooting. And Majid also mentioned, there's really 4 aspects of Day2 operations. There's just the day-to-day routine network changes that you're going to make in your network. There are the routine monitoring that you're going to do in your network. There is the specialized gathering of telemetry, and that goes to what I said a moment ago of when you have a question in your network and you simply want to know, what are the characteristics of certain traffic flows or certain interfaces in my network that are behaving a certain way. What are my bandwidth utilizations and all those sorts of things? And you need to gather that information for planning. And then obviously for troubleshooting, you want to be able to very quickly reach a mean time to resolution or mean time to recovery, MTTR. You want that to be as short a period of time as possible. And that's a big part of what I'm going to show you. But you can see here I've got a fairly simple network up, and this is just sort of my standard demonstration network with 2 spines and 3 leaves in 2 racks. 2 leaves are top of rack leaves in one rack, and the other leaf is just a single top of rack in another rack. And then there are a few servers scattered below this. This is an extremely simple network. And yet with Apstra, what I'm going to show you is the key to how all of this is tracked as a single entity, as opposed to tracking as individual nodes. And we can do that by looking at our Graph Explorer, and that will come up in just a moment here. It's coming up, and there you can see this is the actual graph that Apstra has built from that very simple 2-spine 3-leaf network. And you can see that even at this level, this is enormously complex. And what it's tracking is, and this is the part that people don't see in the beginning, that when we talk about you need to be able to understand your network holistically, we're not talking about just that, yeah, I understand all of the physical connections between all my spines and all my leaves and where my servers are connected and all of that. It's far more than that. There are relationships. Here's an interface connection, and you can see all of the interface connections in this graph. Here is an endpoint policy. You need to be able to understand how your policies are interrelated. You need to be able to understand how your individual device profiles, so what their capabilities are, and how they interact. You need to be able to understand how your protocols are interacting with each other. So the interactions are much, much deeper than just, node A is connected to node B. And this is the key to what Apstra does to treat the network as a single entity. And again, where that's particularly important, and I'll just point out really quickly, you'll notice in this network, there's some red stuff up here, and I'm going to go to that in just a moment. But this is particularly important when you're troubleshooting, because you want something that looks at relationships, not just individual nodes. If you are trying to troubleshoot this via CLI and you're visiting node by node by node, you're not really seeing those relationships, or at least it takes you a long time to gather that information to be able to see those relationships. Apstra is displaying this information to you in terms of relationships right away. And if I go to the dashboard, as you can see here, and obviously things are lit up, and maybe it's the Christmas season coming up, everything here is nice and red and green, but we don't really want red in this case. That's obviously not a good thing. But if I quickly look, say here it says there are 3 BGP anomalies. If I look at those, here you can see that it's displaying these anomalies in terms of what's expected and what's actually there. And that right there, in a nutshell, is the idea of intent-based analytics. The expectations are your intent. And if there's something that is drifting away from that intent, that's shown as the actual. In this case, we have 3 BGP routes that are completely missing. If I go back to my dashboard and I look at the route table, again, you can see that what the anomalies are showing is that we expect all of these routes, and there's quite a few of them, to be up, and instead they're either missing or in some cases partial. And so again, we're looking at and troubleshooting our network from the viewpoint of intent. And I could explore more of these pieces here, but I want to dig a little bit further into this. And one of the things I should mention down here below for node status, you can see that I have my 5 nodes in this network, and that Leaf 2 is showing quite a few more anomalies than any of the other devices are showing. And so already there's a pretty good suspicion that whatever is going on in this network, it's probably going on at Leaf 2. And if I go to my active topology, everything is lit up red here. But if I go down to Leaf 2, I can focus on Leaf 2 and see what's really going on for that specific node, just based on that suspicion that my dashboard gave me. You can see there's some route anomalies, there's some BGP anomalies, but the thing that really is going to pull my attention, and let me go back to the dashboard for a moment, it pulls my attention here too, is there is one config deviation. In our last webinar, I talked a bit about rendered configs and incremental configs in Apstra. And the implication behind that is Apstra expects to have full control over your network and know everything that's going on in your network. In this particular case, this config deviation is really saying a configuration changed in my network, and I didn't do it. I don't know, I meaning Apstra, I didn't make that change and don't understand what it's there for. So there's a really good suspicion that that config deviation is what's causing all of these other problems in the network. So if I just click on config deviation, sure enough, you can see again, I had my earlier suspicions about Leaf 2. You can see that that config deviation happened at Leaf 2. And I can click on this. There's several different ways that I can approach this. Just to go back to what I was starting to do before, let's go back to the active topology, look at Leaf 2 a little bit closer. As I said, there's a bunch of different places I could approach this anomaly. But here you can see again, I have a config anomaly. So I'm going to click on that. And what I get is this. Apstra is saying my intended running configuration, in other words, the rendered configuration, is shown on the left. And there is a difference. On the right is my actual running configuration, and Apstra is raising that anomaly because it says, there's something in here that I didn't do. And in the background, well, I can show you what we have. If I simply apply full config and confirm it, what's going to happen now is you can see that our expected running config is going to be pushed to the switch, and in this case, because it's Juniper, it will be committed, and that config deviation should clear up fairly quickly. And there it goes. You can see that now it's cleared. It will take a little bit more time for BGP to clear up, just from the nature of BGP. Everything has to be monitored, and BGP takes a bit to converge. But you'll see all of that turn green very quickly. You can see that my config deviation has already gone away. You can see that already my anomalies have been reduced. And so that's very quickly going to change. But while we're doing that, I should mention a couple of other things that you can do in the network. I can go to analytics and go to probes, and maybe I want to probe my network for some reason, either because I want to collect information for planning, I want to monitor certain characteristics of my network, or I just simply want to be able to more clearly troubleshoot my network. And you can see that I've already got several probes running. I'm looking at ESI imbalances. I'm looking at route validations for VXLAN type 3 and type 5. I'm looking at my flood lists and so forth. And right now there's no anomalies in any of that. Something I may want to look at, and I can go to active while everything is still kind of clearing up here. And if I look at my nodes, down here on my servers, I've tagged servers for different kinds of services that are supported. Maybe I have one particular service. In this particular case, on server one of, switch two of the first rack and switch 3 in the second rack, I've got this service running on these two servers called Manhattan Project. And I want to keep a close eye on that service. I could go to analytics and create a probe and select. You can actually, there's a bunch of predefined probes. You can also build your own probes, and in a longer webinar we can certainly talk about that. But in this particular case, I'm going to select for critical services, and I'm going to select the tag where I tagged Manhattan Project, which is basically saying I want to watch traffic specifically related to these servers that are supporting Manhattan Project. And I want to be told, in this particular case, my default utilization is 80. I want to say that any utilization over 50% of the bandwidth for those two servers is going to raise an anomaly for me. So I'm going to create that probe. And here you can see the probe. And in this particular case, Manhattan Project was on leaf 2 and leaf 3. There's nothing really going on in my network. So, there's zero utilization there. But you can see that those servers supporting that service are on XE003 on switch 2 and XE002 on switch 3. But now I have a probe that's just watching that critical service and will raise an anomaly if my traffic goes above 50%, because that's a critical service to me. There's other services sharing that bandwidth and sharing those servers, and I want to know if anything else is adversely affecting that traffic. So that's the kind of day-2 operation that you can get using probes in Apstra, intent-based analytics probes. And by the way, you'll notice that finally BGP all stabilized and everything is green and happy now. I do want to show just one more piece of operations, and that's the day-to-day operations. And actually, given our time limit, I think I'm not going to show this piece in much depth, but you know, a day-to-day operations would be if you're creating new virtual networks, you're creating new routing zones. And you know, for a routing zone, I can click on routing zone, and you know, I'm going to actually just take the time. We are recording this, so I think it's worthwhile. If you're operating your network by hand and you want to create a new routing zone, you want to create a new virtual network, you have to visit the devices that you're creating these on node by node. Under intent-based networking, you do all of this by treating the entire network again as a homogeneous entity. So I click on create routing zone, and I'm going to create a routing zone. I don't think green exists yet. I could specify the VLAN ID, VNIs. I select a routing policy, which is just going to be my default. I could specify import and export route targets, but I'm not going to do any of that. I literally am doing nothing but saying I want a routing zone called green. And what did I do here? Oh, I put a space in there accidentally, which was actually a good thing. You can see that Apstra, if you make a mistake in your configuration, Apstra will tell you. So I create that. I give it a moment, and you'll see that my route targets and my VNIs will come up. Here they are. Apstra did that for me. And I do need to allocate an IP address to be used by this. So I'm going to say, let's say that we're going to take an IP address out of the 192.168 pool. And by the way, these pools are configurable. And literally, it'll take a second. This little spinny wheel is the verification happening in the background. And just that quickly, you can see that now I have a green VRF that's created. If I want to create a virtual network, and I'll do this very quickly, I usually create several just to demonstrate, but I'm just going to do maybe one. Let's just call it Ethel. And I'm going to put it in that new green routing zone. I could specify all kinds of other things here. I'm going to let Apstra take care of making all the selections there. I do want to enable DHCP service. I want it to be tagged, and I want it to appear on both of my racks. And I hit create, and it's going to take a second to verify all of that. And now you can see I've got Ethel. I need to specify a SVI address. I do that, and you'll see my IPv4 subnet come up. There it is. Apstra took care of and tracks the subnets in there. And there is one more step, and because I am pressing up, or actually have gone quite a bit past our time limit, I'm not going to do that part. But what I could do by selecting Ethel is go to my connectivity templates, and if I am assigning a lot or creating a lot of new VNs at the same time, I can do this as a bulk operation, go through and actually assign what interface I want, interface or interfaces I want Ethel to appear on. I just said I wasn't going to do this, and I'm doing it anyway. Let's see, let's go to leaf one, and I say I want Ethel to appear on all of those. And you can see that in this particular case, Apstra has returned an error saying that I can't use the specific endpoints that I've used as shown here, and so right away, Apstra tells you when you're making a mistake through all of the validators in the network. And I'm not going to troubleshoot through that. I am, as I promised 10 minutes ago, going to, at this point, stop the demo. And Majid, I'll send it back over to you.
Thanks for covering those details, because I think it's important to have that context when we are talking about things and concepts. So definitely that detail should help. And what you highlighted was how easily Apstra facilitates some of these day 2 operations. And as we were talking, this is just tip of the iceberg, right? And there are a lot more things that go into smooth day 2 operations. So folks who are listening to this, definitely feel free to contact us, and then we can actually go over a lot more details with you in a longer session. And I think one of the things that I wanted to highlight how important day 2 operation is. Your day 0 and day 1, or your architecture, planning, design, implementation, what it does, it builds a strong foundation for you. And how Apstra helps you do that, we can establish that in a first webinar. But now once you build that foundation and then you build that house, and I'm calling your network your house, you live with that on a daily basis, right? So you have that every day that you're living in that house. So this day 2 operations is like that. And sometimes I feel that, the day 2 operation automation or facilities don't get as much important as it should get, because it is affecting every day. And Apstra has done a lot of work and justice in making sure that your day 2 operations are simplified as well. And that's some of those things that we went through highlighting throughout the webinar, and some of the features there. So I'll quickly recap on maybe some of the takeaways, right? For a smooth day 2 operations, first thing I think we talked about, you need real-time network knowledge in context, right? That way, you can narrow down to what you're looking at in short time, and you can do more with less. Second thing is, you want facilities that will help you deal with changes in the network reliably and efficiently. And we talked about how you can do that with the right kind of information at your fingertips, as well as the software doing correlation for you in a manner that's useful, as well as Jeff highlighted, when you deal with the network as a system, and then you can validate everything at every step, right? You are adding that reliability factor as well. And I think last but not least, I think I'm going to be putting on as a conclusion for every one of our webinars, you need a unified solution that offers a seamless automation from day 0, day 1, day 2, and all the way through. It gives you a single pane of glass, and then you can do your operations as good as you can do your architecture and design and deployment. And it's there with you every day to solve and support your network. And with that, I think we obviously can conclude that Apstra does come up great on all these requirements that we talked about. We'll definitely be happy to talk to you more. And in the meantime, you can also do online training, and you can watch a YouTube list. And you can also request for a virtual lab that would demonstrate some of those features with you. So this is great. Hopefully, you find it useful. Please provide us your feedback. And just before we conclude this seminar, I would like to remind you that there'll be a third session that will be focusing on APIs and automation with Apstra. Because you are not going to deploy your network management or network fabric management system in isolation. You have your existing automation that you want this fabric management system to be integrated very well with, and Apstra has paid a lot of attention by providing very simple to use APIs so that it can incorporate in your flows. So thank you very much for listening in, and thank you, Jeff, for sharing additional perspective. Looking forward to talk to you guys more.